Alright, so we're going to look at some more Fletcher trolley questions. This time there's 3 of them, and for my students it's from textbook questions 24, 25, and 26. So for those of you that don't have the textbook, you can see it set up here. You've got a Fletcher's trolley. It is a mass of 1.90 kilograms. It's on the level track. A mass of 0.5 kilograms is hanging over the edge and suspended in the air. And they tell us that there's no friction, so there's going to be much less forces on here. There's no FF, no friction. So we want to know the tension when the mass is released, and we want to know the acceleration of the trolley. I always find it much easier to start with the acceleration of the trolley, so that's where we're going to start. So the F net in this formula is all of the forces that are pulling on the rope. So we have a gravitational force down, Fg2. Fg1 is not pulling on the rope, so it's not going to be included in my F net formula. There's an Fn over here, but again, that normal force is not pulling on the rope. It's not going to be there. There is no friction, so there's no friction to pull on the rope. So the only force that's pulling on this rope for F net is Fg2. So the net force in this case is just Fg2, and that's it. That's the only force, because all the other ones aren't pulling on the rope. So we can work out Fg2. That's mass 2 times gravity. So that is 0.50 kilograms times 9.81 meters per second squared. So that is 4.905 newtons. Okay, and that Fg2 is downward, which is a positive because it's trying to make the pulley turn in that direction. Alright, well that is also F net. But the F net is both masses added together. It's m1 plus m2 times acceleration. That's what F net is. So we would add the 1.9 and the 0.5, and that gives 2.4 kilograms times the acceleration equals 4.905 newtons. So you just take the 2.4 over and divide. And you have 4.905 newtons divided by 2.4 kilograms. And it's just a nudge over 2. You have 2.04 meters per second squared as an acceleration. So now that we know the acceleration, we can take a look at this mass right here and determine the tension that's upward. So we can write for a tension question now. We can write the F net formula, a new F net formula that involves the Fg2 and the tension. But remember, the F net is not 4.905 because that was the F net for both masses. You have to work out a new F net because it's only mass 2 times acceleration. Fg2 is still mass 2 times gravity. And tension, we don't know what it is. Okay, so my m2 times A is just the 0.5 kilograms times the acceleration of 2.04 meters per second squared equals the m2 times g is 0.5 times 9.81, which we already worked out, meters per second squared, and tension. Bring this to the other side and subtract. 0.5 times 2.04 is 1.02 newtons. Subtract the 4.905 newtons gives tension, and the tension is therefore negative 3.883 newtons, which is up. It's counterclockwise, but it's towards the pulley in terms of the direction. Okay, so that's how you get the tension as well as the acceleration in the simple system without friction. So let's look at a different question that now is going to still be a frictionless pulley, but now we're going to take it up a notch and unlock some of our kinematics equations. So we have a mass of 40 grams, that's not kilograms, so you have to convert it, is the one on the table. The 25 grams, or the 0.025 kilograms, is the mass that's hanging, and it's 85 centimeters above the floor. And so what it's going to do is accelerate downward. We're going to be able to find an acceleration. And once we find this acceleration, because we know it's obviously going to spin this way, there's going to be an acceleration. And once we have that acceleration, we can use that with that data and work out the time it takes to hit the ground. So first things first, we're going to find acceleration. To find acceleration, we need ourselves an FNet formula. So we have FG2 downward. And just like the last question, FG1 doesn't come into play because it's not pulling on the rope. There's no friction, so there's none of that. So the only force you have at play on this one is, again, FG2. So my FNet is just FG2. FG2 is 0.0250 kilograms times 9.81 meters per second squared. So my FG2 is 0.24525 newtons. Now that is equal to the FNet, which was both masses added together, remember. So this is M1 plus M2 times the acceleration. So if we add both of those masses together, you get 0.65 kilograms times the acceleration is equal to the 0.24525. So you would divide those two. So 24525 newtons, divide by 0.065 kilograms, and that acceleration is going to be 3.77 meters per second squared. Now that we know the acceleration, we can turn this into a question that we used to know here to get distance. So it started with a VI of 0. And you know so you're looking for a formula that has distance, acceleration, and time. The formula you need to use is VIT plus 1/2 AT squared. And good news that VI is 0, so that term just goes away. So you have distance equals 1 divided by 2 AT squared. So if I'm going to rearrange this to solve for time, just like last chapter, you remember the 2 is going to go up. You're going to get 2 distance equals AT squared. The A is going to go down, and you're going to get 2 distance over A equals T squared. And then you're going to square root both sides, and you're going to get the square root of 2 distance divided by acceleration. So my time is going to be the square root of 2 times the distance, which was 0.85 meters, divided by my acceleration, which was 3.77 meters per second squared. So when you divide those out and then take the square root, you should get 0.67 seconds, which is the time it takes for that to go down and hit the ground. So, question here, didn't have friction. You just had gravity fueling it. You make sure you divide by both masses to get acceleration. Once you had acceleration, you're just back into those old questions that we used to do. Last question, of course, we can't pass the opportunity to have 3 masses in the question and have friction at play. So we're going to have lots of forces now in this question, plus you know the distance that it hits the ground, so we're still going to want the same formula at the end of all this. At the end of this, you're going to want to do the square root of 2d divided by a, the formula that we just had. That's what we're going to want to get at the very end. But again, we need to do some work to get the acceleration. Alright, so I'm going to draw a lot of forces. We're going to do an F net before we come back to this right here. Alright, so what do we have? I'll switch colors. We have FG1. We have FG2, or 3, excuse me, FG3. So those two are pulling on the rope. I have FG2 this time, which is not pulling on the rope, but since there's friction, we need to work it out. Because FG2 will be the normal force, friction is going to be back in this direction, and it's going to be mu times that normal force. So I'm just going to work out all these numbers separately before I start plugging it into the formula. Okay, so we have FG1 is going to be mass 1, so 0.228 kilograms times 9.81 meters per second squared. So this comes out to 2.237 newtons. M2 is going to be 0.615 kilograms times 9.81 meters per second squared, and that's going to come out to 6.033 newtons. That means I know my Fn is 6.033 newtons, which means I can get Ff, which is mu Fn. So it's 0.26 times 6.033, which means the friction comes out to 1.59. No, 1.569 newtons. 1.569 newtons is friction. The last one way over here is FG3, which is M3, 0.455 kilograms times 9.81 meters per second squared. And FG3 is 4.46355. So I haven't labeled any directions yet. Okay, so FG1 is trying to make the pulley go that way, so this is a negative. FF is also trying to make the pulleys move that way, so it's a negative. FG3 is trying to make the pulley go this way, so it's a positive. And those 3 forces are the only forces pulling on the rope. So my F net is FG1, FG3, and friction. FG1, FG3, and friction. My FG1 is a negative 2.237. My FG3 is a positive 4.46355. And my FF was I wrote a plus, but it's a minus. My FF is a minus 1.569 newtons. So when I take 4.4, subtract 2.2, and subtract the 1.59, I get 0.658 as a positive. So it's a positive number. That's what F net is. F net is all 3 masses added together. It's M1 plus M2 plus M3 times A to give that 0.658 newtons. The three masses of 0.228, of 0.615, and 0.455 all add up to 1.298 kilograms. Dividing by dividing that 0.658 by the 1.29 is going to give us our answer. So 0.658 newtons divide by 1.298 kilograms will give us an acceleration of 0.507 meters per second squared. Once we know the acceleration, we knew we were off to the races because we could go right to the same formula that we had last time to work out the time was the square root of 2d over a. If you remember from what we wrote down at the beginning, you have 2 times the distance, which was 1.95 meters, and now you're dividing by this acceleration of 0.507 meters per second squared. So if you do 2 times 1.95, divide by the 0.507, don't forget to take the square root. The answer should be 2.77 seconds as the time it takes to hit the ground. Okay, they're definitely tricky questions. I'm not minimizing it to say it's easy. Hopefully with those as some models, you're able to have success as you work through these questions.